so today we're talking about energy terms. This is the second time filming this because I mucked it up the previous time. But we're going to be talking about the words endergonic, exergonic, exothermic, endothermic, catabolic, anabolic, all these terms. What do they mean? Okay, and how do they relate to the energy that we're going to go through in biology here? So, and exergonic, exothermic, and catabolic, all of these terms are going to relate to cellular respiration. Okay, exergonic, energy leaves, energy out, or I think energy exit. Okay, exergonic, energy exit, energy is going out. Same, and so that's why it's exothermic, or yeah, exothermic. Energy is leaving. This thing's going to be hot to the touch, or warm, an increase in temperature, because it's giving off energy in the form of thermal energy. So it's going to be exothermic. And then catabolic versus anabolic. I just remember this by the fact of anabolic steroids. And so, you know, this is tear down or take apart, and this is build. Okay, so in cellular respiration, we have our glucose that's up here, which is the C6H12O6, and that gets broken down into our water and our CO2 in cellular respiration. We're going from a high energy state to a low energy state, and so both thermal energy and Gibbs-free energy is given off. So this is both exothermic and exergonic, a catabolic reaction. You're taking stuff apart. Photosynthesis, totally opposite, the exact opposite. So we're taking our CO2 and our H2O and our water, and we're turning it into glucose. So we've got to take energy in. Endergonic means energy in. Same thing with endothermic. Energy's coming in. Thermal energy in. Now we don't really notice this on photosynthesis because it's getting the energy from the light instead of from the surroundings, but in the same principle as far as we're taking energy into it. And so if it's taking energy in, endothermic energy in, it's going to feel cold around it because it's taking energy from the surroundings, excuse me, and going into that object, so it's going to feel cold to the touch. And then once again, anabolic steroids, you're building something. So we're taking these less energy parts, they're smaller, more basic, less molecules, so there's less bonds, less energy in it, and we're making this high energy molecule glucose, remember C6H12O6, and the energy we're getting to make this comes from the sun. Okay, another thing I wanted to add, just a side note, I just saw this in my notes. Okay, so spontaneous versus non-spontaneous. This is a spontaneous reaction. And this one's non-spontaneous. Non-spontaneous. And it's spontaneous because think about it like a slide. You're going to be able to slide down a slide, but you need energy to climb up the slide. So just, if it's spontaneous, it can happen automatically. And it's just like a slide. You're going down a slide, going down a hill. It doesn't take energy to go down the hill once you get going. But if you got to go up the hill, you're going to put in some energy and it's going to take some work. And I hope that was helpful.